All right. Hello, hello. In the previous episode, we got some nice way of defining this scene or this world, I guess, that my player is walking on. Before it was just completely hard-coded. Well, it's still hard-coded, but that's not the right word, maybe. But it was all over the place, because this world is made up out of there's collision triangles that my player is walking on right now, and there's also the stuff that's being rendered. So what I did in the last time is I just define this shape that you see here, this brown shape, as a polygon. So it's a set of points into this space, and they're ordered in a clockwise direction. And using that, I made this triangulation function that converts this polygon outline into a list of triangles. And those are the triangles that we're seeing on the screen here, that we're using for collision and also rendering. Right? And we also put this grass here procedurally. So if I change this shape in any way, let's try to do that maybe. If I lower this left point, yeah, you see the grass grows correctly on that surface. Right. And I guess like the problem is now that these are still defined in code, and that's not very nice if I want to make a game, I think. So I want some kind of editor or some kind of editing for this, so I can like click on points and move them around and stuff like that. Yeah. So that's what I have to figure out today. I think the actual editing part is pretty easy. Like, it's just a matter of moving around, like changing the position of a point, right? And updating the triangle data. But there's some... I have to take into account the code structure of all of that. Like, we want to have some kind of edit mode, right? That's what I'm thinking right now, at least. So this is gonna be like a regular game mode, I guess, where you're actually playing the game, right? And yeah, I think I want some separate edit mode, where if I switch into that, I think the game logic should probably stop completely, or maybe pause, whatever. Yeah, so we need some kind of state to handle that, because I don't want the editor to be a separate program. I want to be able to press like F1 or something, and have it switch into this edit mode where I can drag stuff around. All right. So how should we do that? How should we do that? We could have some kind of... I was thinking about this a bit before also. But I guess on a high level, we want some kind of mode. I guess application mode, maybe. Let's call it app mode, maybe. So we'll have some edit mode. Well, let's make the game mode the default, actually. First one. So we have the game mode and the edit mode. Okay. Oh. Oops. Typed this one. And yeah, let's initialize it, of course. Alright, so we have this mode now. And I guess there are some places we have to take this into account now. So... Yeah, we're ticking the game here, for example. And we should probably not do that, right? So if we're in the game mode, we will tick the game. Seems pretty good. And there's also a function to render the game, which we can just skip, I guess. For now, that doesn't actually do anything, except for, I think, drawing this debug box of the player, right? But there are no models right now that the game logic is actually rendering. All right. Well, the important thing that it actually does do is it sets the camera. So, right, because the scene rendering needs some kind of camera, and that's sourced right now, or it's set by the game. So I guess we instead, if we're editing stuff, we want to have some kind of different camera controls. So we need to get that camera from somewhere if we are editing. And maybe I should add some kind of editor state, editor interface. Let's call it editor.h. And let's have some kind of editor. And I guess the first thing we want, well, I guess the editor should probably have some kind of update function. Yeah, I'm unsure if the editor should draw stuff. Oh, well, yeah, it should obviously draw stuff. Maybe we'll do that first. It should probably draw this polygon in some nice way. And let's add these functions that I have on every interface. We want some way of creating the editor. And in here we probably want to pass a reference to the world, because that contains all of the polygon data right now. And we want to destroy it when we shut down the game. Let's allocate that, zero initialized, just how I like it. And I guess we should also, we need to define this. And what data should the editor actually have? So it should have its own kind of concept of a camera, right? Right. So there should be an, I guess we can call that just camera. We also define a camera, well, let's call it editor camera, because just in case we get some name collisions later. So I feel like this should be pretty similar. It just needs some kind of focus point, right, that we're looking at. And we should also have some kind of zooming in and out. Right. How? Well, I did this in the game already. We can do it the same way. So there's the camera. Yeah, the height represents the zooming factor. So that's how much of the world in meters, I guess, that the camera should see or cover. Right. So if we lower this, it's essentially gonna zoom in. Okay. So the editor has a camera. And we should probably keep a reference to this world, right? The editor has to know about the world because the data of the polygons is stored in there. And then we need some kind of interface, I guess, to access those somehow later. And just keep a reference to that for later. And that should be it for now. Alright, so we want some... do we call this draw or render? Yeah, render, right? So... right now, the way of setting the camera... the game sets the camera. I have this SCB, which is the scene command buffer, right? And we set the camera inside of that command buffer. I guess in reality, I don't have to pass the scene command buffer because it has a bunch of different stuff. You can draw models and add lights and stuff like that. Well, okay, let's. For now, we can pass it, I guess. So we pass this scene command buffer, so we can set the camera when rendering the scene. Okay, so I passed the scene command buffer first in the game version here, so I'll do the same. Okay, so let's add this editor state into our application now. So we create the editor, pass the world in there.
Took a steady climb with the gradients against her, but she's on time.
Well, maybe we can do it here by the game. They're kinda similar, right? Alright, so we have the editor state now created. So let's just render the editor state. Okay, so I guess we also need some way of switching between these application modes, the game mode and the edit mode. So I think I added we can check for a key press here. So if we press let's use F1. If we press F1, then we'll do it like this right now. So, okay. That should work. And maybe there's some stuff we have to do at the moment that we should actually switch. I can imagine that, like when you switch into edit mode, you probably want the camera to be in the same same place where you left off while playing, right? But we'll take care of that later, maybe, because I can at least see some situations where we want to do some more stuff there. So I actually wonder what's okay. So this isn't implemented, right? So in here, we want to set the camera, and I will copy paste the camera code that we have for the game right now. So we have some calculate camera function, yeah. Let's put some our static functions up here. I think I like that. And implement them at the bottom. And we're gonna use the editor camera instead. And that has all the same data, so that's just gonna work. That's nice. And we'll pass the editor camera. Right. And we need the aspect ratio. So yeah, we need the aspect ratio. And how do we do that in the game? We pass this game viewport. Why did I call it like the game viewport? I mean, I can make this a shared type, like just some viewport type, right? But where to put that type, I guess. We have this types.h. Yeah, why not? Why not? So instead of the game viewport, it's just some viewport, right? Well, it's not really a viewport either. Viewport usually has like some offset. So I mean that's just a uint2, right? So let's just delete that type. And call it, and it's not even the viewport, it's like the resolution, right? Right. Like that. Right. Well, it doesn't even have to be a pointer. That's just unnecessary, right? All right. Right, this is like the well, I guess I can. This is a Vulkan type right now. I can just use my own now. I feel like that. And I could use. Yeah, let's do that. Let's make some quality of life improvements here. So, because I didn't have these types before, but I think it's kind of nice. So let's pass the size here instead of the width and height separately. Like so. So let's see where we are using this width and height. That was a unit, yeah, okay. Size. Why is the IntelliSense so fucking slow? Please update. Please. I need you. I need IntelliSense. Oh shit. Window.h. Yeah, we have to include this. Types.h. Right, so instead of the game viewport, we just send the resolution now, and there are a couple of more places. Right, now we can just pass the resolution here into the window create, at least, and create swap chain. Just change this to unit 2. What, my Visual Studio Code is completely fucking broken. I can't switch between files even. Oh, Jesus Christ. I'm triggered. I need IntelliSense and shit. Render targets. Yeah, of course. Include the types. Let's do it like that. We take the width and height. Where is this implemented? Change that as well. Okay, that's actually... Okay, that's annoying that I have to convert this now, but whatever, not a big deal. I'm still not sure if I want, like, do I want to add spaces there? I don't know which formatting I like the best. These are the big questions in life. Right. Yeah, instead we're using the Vulkan stuff everywhere, like this extent. And I hope this is a good choice, that I'm choosing to use my own type here. I feel like it is. I feel like it is. Hello. Right, I also have to convert this. Oh. Was this a mistake? I don't know. I don't know. And I mean, I could just cast it also, but no, that feels even worse. All right, finally. So for now, let's pass this resolution into the editor render function. So we can calculate the aspect ratio. Too few arguments, yes. Obviously, like that. Okay, good. And let's try. Okay, so I mean, it is possible to switch. I would expect. Oh yeah, the camera is not. It's not drawing anything, but I think that's because I forgot to initialize the actual height of the camera, or the size of the viewport, right? So let's set that to some value. All right. That is something. All right, so I can essentially switch to an edit mode now where I have a separate camera, right? And I guess now I want to add some kind of camera controls. So how do I actually want to control the camera in the editor? It would be nice to... I have two applications. It would be nice to drag it around. I think that would be nice to like click on the screen, right? And yeah, instead of using arrow keys, it would be nice to be able to drag like this with the mouse. Yeah. So let's try to add something like that. So we need to add some input handling, to the editor interface also. So I guess first, so when we pull events from the operating system, right, for this window, the key presses and stuff, we just pass it along. We pass it along to the game, and the game. I mean, check for key presses and stuff like that. Like I'm moving with the arrow keys and stuff like that, right? So we first want to check if we actually should process input, and we should only do that if the game mode, or the gameplay mode is active. Otherwise, we want the editor to process the input, right? All right. Oops, window. And I guess that's like a window event. Yeah, window event. How did I call that? I called it event, right? Let's do that. Let's not do a shorthand single letter. I was tempted though. Alright, so we want to process some kind of mouse input here. So, well, I guess we want to track when we click the mouse or hold the left mouse button down, right? And when we release it. And we also have to process actual mouse movement. Right, so I think, okay, let's first let's check what event type we got. So button is a mouse button, yeah. So if we press down a mouse button, we have some yeah, we have the which button it was. So I want to use the left mouse button for now. Okay, so if we press down the left mouse button, I do wonder, like, do we get from? Oh yeah, we have the X and Y position as well. Okay, that's very useful. Okay, so we want to basically keep track of, I guess, where we started holding down the left mouse button. So that's a uint. Well, let's make it an int, assigned int vector. That's gonna be easier. So yeah, let's store that in the editor. So what would that be? I guess mouse drag origin, maybe. What's this? Do I not have a assigned int2? Apparently not. Let's add one. Like so. Right, so when we press the mouse down, we want to save this this position. All right. And we also want to do something when the mouse moves. And I think when we move the mouse, we want to create some kind of vector, right, from where we pressed down the mouse towards where we are currently. So like basically how far we have dragged the mouse since pressing it down. So we can call it mouse drag delta. And that's going to be the difference then. So I'm wondering which direction like we should store this vector as. Like should we point towards where we moved the mouse? Yeah, I feel like that makes more sense. That makes more sense. So we can check where we currently are on the screen with the mouse, right? And subtract it by this origin. All right. And now using this, well, for now, let's say that so the camera will have some position, and while we're dragging, I don't want to change the well, I do want to change the position immediately. However, I also need to keep track of, like, when we start dragging with the camera, I need to know where where the original position was. Yeah, so I think that's probably a good way of doing it, sure. Let's try this at least. Right. So the origin. So while we are holding down the mouse button and changing the position, the effective position of the camera, which changes position, because the calculation I want to do is, I guess, we have this delta, right? And I think the first thing we should do well, I guess we can skip. We can try doing this in the render function. So we want to change the position of the camera somehow using this this amount that we have dragged the mouse. So we want to move it from the origin by some factor, right? And let's just try this and see what happens. Did I forgot to, yeah, I should send in the editor here. Alright, so into edit mode. Oh. Oh, I forgot something. This. Right, we should only do this, I guess, if... Yeah, we have to know whether we are holding down the mouse or not, I think. So let's keep that state. Mouse. Let's call it mouse down, or let's call it mouse dragging. So when we press down the button, we have to set this to true, and we gotta check when we release the mouse button. We should set that to false. Okay, one more issue. This delta. Yeah, we reset this. We zero this delta. Wait, does this... How often does this fire, actually? It seems like it's firing every frame. Hello? What? Am I... Why isn't it printing anything? Oh. Oh, I'm stupid. Oh my god, okay, I forgot. Okay, there's still something... Alright, never mind. So... Okay, so... Now there's gotta be a better way to do this, I feel like. Well... This is a lot of state. It's really messy, I feel like. So what's an alternative? We could when we click down the mouse, we can instead, I think, save the world space position of where we clicked. I think that's a much better alternative. Let's try that. Yeah, let's try that. That's a vec2. Okay, so instead of like in screen space and stuff, we will, yeah. Yeah, okay, so how do we do that? I guess we can just use the camera here, because it's gonna be like this, the camera state from the previous frame, right? But it's probably fine. So we want to somehow project this screen space mouse position into the world, right? So we know where we click on the screen. Right. And I think the first step is to convert it into UV space. So we take the position in pixels and just divide it by the resolution. And I guess for now, yeah, let's just save the resolution in the editor also. And when we render, we just save that. Like that. Okay, so that's the UV space. So normalized from 0 to 1, where we are on the screen. And I think we want to convert this into normalized like NDC space, which is from -1 to 0, 1 in each direction. And to do that, it should be simple. Just I need my math functions, my vector functions. So we just scale the UV up by 2. And then subtract 1 from each axis. Right. And let's try then. So we have this mouse click in NDC space, and we know where the camera is. If we subtract those, we should have some kind of vector now that points towards the mouse. I can't actually do debugging here. Shit. Well, we'll just save this. Yeah, let's save that. And then we can try to draw where this point actually is now. So let's draw a line. Well, we can draw a point. Draw debug point. Debug vertex. Right. We have to flip the y-axis. We can just do that here. Like that. Right. Oh. And we have to scale this up. That should be fairly simple. I need a multiplication. So a vec2 mul for multiplying two vectors together, because you have to scale this up a bit. Like that. So let's multiply this difference in normalized device coordinate space by some factor, and let's ignore the height for now. Multiply that by 1. But I think, well, no, let's ignore the width. So the height, we already have that. We have the camera height. Right, we don't actually want it in NDC space, but it's gonna be kinda. It's gonna be like we have to shift the UV only, okay? Because the height, half height, okay, makes sense. So we don't scale the UV. We only subtract. We center it basically. So the extent of the UV is still 0.5 at each corner of the screen. Alright. And now for the X direction, we actually have to... We need the aspect ratio again. Alright, so that works. So I can now click. I can click into the world, basically, I guess. So when I click, there is some corresponding world space position that I'm actually clicking on, right? That's nice. And what I think I can do now is that dragging, when I drag or want to drag the camera, then all I have to do is, if I hold it down, like on this position, for example, and drag my mouse here, it should be trivial to, do the same thing. Like I project that point into world space, essentially, and if I calculate the amount in world space that I want to move the camera, like I can just move the camera then in that by that amount. So that feels a lot simpler than what I was doing before. Right. So I want to do this for more points, and I can probably just create a function for this, for basically, so I want to project I want to project the point from the screen to the world, I guess. Nice name, bro. So we'll have the point in screen space, right? Well, screen space, yeah, it is screen space. It's like pixel space, I guess, or something. But I'll call it screen space. And we want, well, I guess let's just take all of this and see what we actually need. Right, so we need yeah, we need to pass the, well, we can just pass the editor. Yeah, that's fine. That's fine. Editor, right? That's fine. Right, that is fine. Right, and we get the camera in here, and now the aspect ratio. Right. Well, oh, we can just compute that. Right, and let's just return that. Okay, that's it, right? So now we have this function for that. Pass the editor here, and the point on the screen is going to be this. I'm tempted now to actually also change this so that it's just returning the yeah, I will do that. Watch me. So just do that. And this is the exact same. Exact same position XY. Yeah, makes sense. That doesn't have to be on 2 lines. Okay, what did I mess up? Okay, there's more places, of course. So let's just do the same thing. Oh, it's inside of a right. There shouldn't be a semicolon there. Of course, it's inside of a initializer list. Well, I mean, I could just do this, right? That's maybe nicer. God. Okay. Nice. So now I can just use this directly to pass that in there. Okay. Nice, still works. Okay, so now I guess when we are dragging the mouse around, so instead of the wait, hold on. Let's say we have the target here. So the target, and that's just gonna be a right. So if we are dragging the mouse, we will set this target thingy to the current position. And set the target, initialize that when we actually click down the mouse. Right, and we have some more. Right, yeah, let's change this as well. So we'll have the position and the delta as our int2 types. Yeah. I like that. So the pos and the delta. So compute the drag delta here now, which will be the target minus the origin. Like that. And I forgot that there are no operator overloading in C. Right, the game also needs some fixing these events changes. Okay, nice. It's reversed though. So I guess we will flip this delta computation. Okay, that works. However, let me think now. Let me think. I mean, it works, but it doesn't actually like move. Right? When I release it, so I think I want to then I probably want to catch like, okay, so if I release the mouse, I want to actually move the camera, right? So it's kind of double buffered in a sense, right? I'm buffering the movement while I'm holding down, and when I release, I want to change the position. I think that makes sense. There's probably likely some simpler way of doing this, but it feels like I have to keep track of a lot now. Like when I release it, when I release the mouse now, I actually have to do this computation again, right? I have to do this again. Let's try that at least to get it working first, right? Right. So when we release the mouse now, I want to change the origin point of the camera. So that seems fine. And let's do that. That's working. However, why is this world space position completely... Why is it completely off? I think I might know why. So I think this is wrong actually, this function. Well, should we be adding these instead, right? So we have in screen space. Yeah, I feel like that's. No, it's not that either. Well. I mean, I guess I don't actually have to do anything here. Let's try to not do anything with this point. When I like when I move off the center, it's Okay, this feels like it makes sense. And so I feel like all I have to do now is like add the. Don't I just have to add the origin, or what am I getting wrong here? Oh well, right. I think I know. So. Right, we need this into world space first. Right, so this is projecting it like actually into world space, and then we can take the world space plus the origin. That should be it. Yes. Okay. So what point am I actually... I'm drawing the drag origin, and well, why is the origin moving? It should only be set when I... Okay, something seems weird here, but I don't think I have to... I probably don't have to bother. Okay, so that seems fine, I think. So I think anyway, I do want to keep track of the current mouse position anyway, because I think that's gonna be useful. So when we move the mouse, just update that. So we have the mouse position here from the event. Data mouse pos. Alright, so using this mouse position, I want to try this now. So like, maybe we should create like an update function in addition to render function here, but do I need the aspect ratio here still? Okay, right, for calculating the camera. Sure. Okay, so I want to try to just project this mouse position on screen into the world now again. So world mouse pos. Alright, so let's try to draw that point. As yellow. Okay, I see a slight issue. Okay, whatever. whatever. It's not really an issue, I think. Okay. I don't have to care about that right now. Right, because the point is... Oh well. So... I think I want to change this to the right button mouse. All of this camera logic. Maybe we could even have, maybe like if you press down Control. The right button on my mouse is kinda messed up. It's like sometimes it just releases itself. It's really finicky. Okay, but now I can move around in the edit mode, right? In a nice way. So I feel like the next step maybe could be to make it possible to drag around these vertices, right? And how would I do that? So I need some way of querying the polygon from the world. I think that's what I need. So, in order to do that, let's add some function to the world. I guess that's let's call that edit info. Or editor info, no edit info, let's call it edit info. And that should contain the polygon. And the polygon right now is a private, it's a private like type, right? So we have to expose that. Because I want the editor to just modify this data directly. I don't see really a point in creating an API for the actual like modification of Vertex data. I don't really see a point in that. I think this is fine. So I guess we will get a list of polygons, some number of polygons, right? So I have the polygon count and the actual data of the polygons. Makes sense. So we'll have to retrieve that some way, calling world get edit info. Info from the world. Like that. So for now, we only have a single polygon in the world, so this is gonna be simple. That's it. Like we pass out this one polygon that we have. It's that easy. And now in the editor, right now we're doing all of the logic in this render function, which at some point I'll split it up. But it doesn't really matter, whatever. They're still going to be called once per frame. Who cares? Okay, so if we want to be able to edit the world, we will get this edit info. Let's click world info. And we saved the world from before when we created the editor, so we have that. Right. I guess we can start with trying to. Well, we'll have this mouse position in world space. So let's write a function to find the vertex that we are closest to with the mouse. Okay. So Well, for now, let's... I mean, we know that there's only one polygon, so let us... let's pull that out from the world in info polygons. Alright. So the polygon has some number of vertices. Let's go through all of them. And we have to keep track of the closest distance, which common thing is to just set this to the maximum possible floating point value. Right, because what we want to do is for each vertex we want to get some vector from the mouse to that vertex, right? So we have the vertex position as P, and if we subtract P from the current mouse position, and I guess we can immediately just take the length of that. Okay. Right, so we have some distance from this vertex to the mouse. So if that distance is closer than the closest distance we recorded so far, then we also need to keep track of the closest vertex, which we don't even have to initialize that. Well, maybe we'll do just for safety's sake, I guess. So if we come across a vertex that's closer than the current one, we store that distance as the closest one. Right, and this closest vertex is going to be the index into this polygon index list, polygon vertex list. Right. So once we have that, and right now, yeah, let's do it like this. Okay, so we will have a closest vertex. Right. So let's just draw that vertex with some color, and that's going to be, so we have the closest vertex. Let's call it closest vertex index, and we will have the actual. Well, no, let's not. That's too long. Okay, so because okay, so then we'll get the polygon vertex. We'll get the position of that closest vertex, right? Closest pos, and just draw that. Okay, that's working. That is working. Working fine, yeah. So now that we know the closest vertex, we should be able to essentially just grab it, right? Grab it and drag it around somehow. Right. Yes. All right. And how to do that? Like, it's a bit messy, right? Because this input stuff is... The input handling happens at a separate place, right? Like basically at the start of the frame. We poll the window system for some events, like pressing the mouse and so on. So if we want to know... I'm wondering which state we have to keep. Like what should actually happen when we press the left mouse button. What should happen? I think I guess maybe the easiest way So I guess let's at least keep a reference to this closest vertex. So we'll have the closest polygon and we have the closest vertex inside of that polygon. Makes sense. So when we calculate this here, let's save that. Let's save that down. So, because we need to basically know about this when we are clicking the mouse button down, right? And that happens at this separate place. That should be fine. Okay. So, I guess we also want to know, like when we click down the mouse button, we want to start dragging this, right? And I think it would be useful to keep track of that as well. So, we keep track of which polygon we are editing right now. Basically dragging around, right? We'll save those as well. So when we are clicking the mouse button down, so if we click the left mouse button, what we will do is should just save this, I guess. So the polygon that we are editing is going to be the closest polygon right now, and the vertex that we are editing, that's the same deal. That's going to be the closest vertex, right? Right. And then when we move the mouse, I guess first let's check what's gonna happen when we release the mouse. I guess we'll set this edit polygon to null, because then we are not editing any polygon anymore. Let's set that to 0 as well, just to be safe. Okay. So if we are moving the mouse later, then and if we have a polygon that we are currently editing, what we want to do, I guess, is just look inside of that polygon, right? And I guess we want to do we want to project, we want to know the world space position of the mouse. So world mouse world pos, I guess, like that. Yeah, and let's just try setting the position of the vertex then. So we have the list of vertices here in the polygon that we are editing, and we know the vertex index that we want to edit, and let's just set that to the world position of the mouse. And let's see what happens. Okay, so if I pick this, that is working. Now, I guess the only problem here is that I guess we have to notify the world somehow of our change. Right, we have to notify the world of our change. Well, I guess the simple thing would be we could just rebuild this. We could recreate the colliders every frame, right? Let's try to do that first, at least for the colliders. And then about the rendering stuff, we will see how to solve that. But so let's just say when we update the world, just do this triangulation again. Right, and that should solve the case for the collision triangles. Yes, it does. Oh, that's cool. Oh. Oops. Oops. Okay, maybe that shouldn't be a crash. I made an invalid. Oh shit. I think I made an infinite loop there also. Okay, so the triangulation is a bit wonky, I guess. But we can move this stuff around. Okay, so now what would be required? What would be required for us to actually... This might be a bit dangerous, but let's try to just always run this. There are some obvious problems with this. Okay. Why? Why is there nothing? That's not what I was expecting. Not at all. Oh right, right. I checked this state. Right. Of course. So let's. We should probably handle this in a different way. Maybe it shouldn't be. Maybe it shouldn't be a state really, but let's keep track of whether the is render data uploaded. Let's keep track of that instead. Well, that's always gonna be true, right? Okay, let's forget about that for now, and let's just remove this. Okay, that's working. So I am using the standard library random number generator right now. Editing is working. Cool. But yeah, I should reset the seed for this random number generator before doing this procedural generation. So let's Let's set that to some fixed seed. That's good. Oh, that's cool. That's cool. That's cool. It's stable. Like even. Oh. Oopsie. Okay, that's really cool, actually. Really cool, and like there are some really. My triangulation is not really as robust as I would want it to be, because there are some random hangs and crashes. Yeah, like this, like I guess for that one I can try this actually. Let's triangle. Where's my triangulation function? Right. Let's. There's kind of two problems right now. Let's try this. That might improve some things. Oh no. Okay, so maybe we can look into that next. Maybe improving the triangulation a bit, because one problem is if I move this triangle down across this line. I haven't solved that case yet. Yeah. Crash. But I mean, if I'm careful, and when editing the world, like. I'm actually surprised that this is so stable, or should I be? I mean, it seems. I'm not complaining, but it's just. Oh shit! It's a bit surprising. Yes, that is not flickering as much as I would expect it to flicker more. Okay, but I really like this. Very cool. The possibilities are endless. And let me think. If I move this up, will it crash? I don't think so. It does. But why? I guess I have to implement this this missing part of the algorithm, maybe. And I think maybe I probably want to like actually have some function that verifies that the polygon is triangulatable. I guess if it's valid. So I guess this is the restriction, right? The polygon has to be simple. Yeah, the polygon has to be simple. And if I can just verify that, I can like just, I guess maybe start with not attempting the triangulation, right? And somehow signaling some kind of error, right, to the editor. Something like that. But I think there is one part that I'm actually missing, which is figuring out this should clip, which is essentially, is pretty simple actually. I just didn't bother to implement it, but it is this one. So for each vertex and corresponding triangle, so when we're going through this, there's some good visualization. We're going through this triangle, this polygon, and finding, we're picking 3 consecutive vertices to make a triangle, right? So there is a start and a midpoint and an end point, right? And this midpoint, so for each midpoint vertex of each triangle, right? We test all other vertices to see if any are inside the triangle. If at least one is inside, you do not have an error, which means that we should just skip it. I think we should just skip it if the if any. Yeah. Okay, we can try that. So we have some triangle defined by some consecutive points on this polygon, right? And we want to check every single other vertex of this polygon to check if any of those points are inside of our triangle. All right, and how can we do that? We already actually do that. That's actually, well, we do need a function for that, I guess. So we want to know whether is point inside triangle. Well, maybe not actually, because we can be a bit more clever about it, I think. So the way that we can check whether a point is inside of a triangle is to, we already do this actually for the collision detection here. We basically create planes on each edge of the triangle. So we have 3 planes per triangle that are with a normal that's pointing outwards, right? So what you do is you have 3 planes, right? And for each point that you want to test, then you check which side of this plane that the point is on. And if the point is behind all 3 planes, then you are inside the triangle. Pretty simple, right? Because the planes are like signed, like they're pointing outwards. So if you are behind the plane normal, then you are inside the triangle. So let's try that. I already do that here, so let's see how I did that. Right. I guess we can take this directly from here. So we'll have 3 planes that lie on each edge of this triangle. Right. And I guess we also need this this list of edges. Right. So an edge is defined by 2 vertices. Right. Well, do we actually? Oh yeah, we need to know. Yeah, we need one point here. Okay, so let's say P0, P1, P1, P2, P2, P0. So those are the three edges of the triangle in clockwise order, right? And then for each edge we compute the normal, right? And figure out the plane, right? I guess we could add this. We can add this back. For debug purposes. The count of is defined there. All right. Oh, it was hard to see, but there is in fact a normal pointing here. Okay. Makes sense. Okay, that seems to be working. Right. So now let's go through each point in the polygon. Well, actually, in the working set, because those are the only ones that should matter, right? So we want we want to check every other like all vertices except the triangle we are currently testing, right? So I guess the number of checkpoints. Well, test count. Maybe well, inside test count. Yeah. So how many vertices are we gonna test? So we know the size of the working set. How many vertices we have to process? Yeah. And if we subtract 3 from that, because right now we have a triangle, right? In this current step of the algorithm, we have 1 triangle, so we don't have to check those 3 points. Okay, so we know how many points we have to check. And now, what about... Right. So let's go through all of these tests we have to do, and the actual the index of the vertex that we want to test is going to be the vertex that's behind. So let's say we are checking well, this, and this triangle. We want to skip ahead and check if this one all around until we reach this one. Okay, and we know this index of the last, that's k. That's K. Alright, so we have K plus 1, right? And modulo that, or wrap it around with the working set size, so we're not out of bounds. So we loop around. Right. Makes sense. So then we check the working set. Let's do that. So then we have the actual index of the vertex inside of the polygon. So then we can get the position of that. Okay, so we have the position we want to test. And that's test. Yeah, it's like this, right? Let's see, we maybe don't need a loop for this, right? Probably. So we want to make 3 plane tests. Yeah. We want to check plane 0. Well, do I have pos? This function is getting so, like, it's hard to know which which variable names I already used. I'm out of iterator names for the moment, so. Okay. Like that. So what we want to check yeah, we want to check that this is below 0, right? Well, if all of the 3 planes are below 0. Well, let's make it like that, just to be sure. So, okay, we have this should clip. We can move that down here. So that's what we're trying to figure out here, right? When we're doing these intersection tests. And if we have one point now, I guess, that is behind all planes. So we'll check 3 planes. If that is the case, then we should not clip this triangle. Let's see what happens. Okay, so let's try to figure out a case where it would have failed before. I'm trying to think. Well, oh, that's an infinite loop, okay. I have to figure out why that can happen. But I think that's a separate problem, probably. Or maybe not. Yeah, okay. I wonder how to debug this in a nice way. Is it like there's a lot of floating point stuff going on here, right? Okay, so that's a guaranteed infinite loop. But why? Why? Like, I suspect if I move this up above this line, I'm gonna freeze. Okay, yeah, well, it freezed now. What could be the problem? I guess I gotta... I guess I can print out some data, right? Maybe, and see what the state is. So what has to be happening, I guess, is that for some reason we get stuck when we have, I guess, maybe some two triangles. I can try to make this this polygon a bit simpler, just for testing, right? So let's say we have a 4. If we have 3, let's try with 3 as well, I guess. Okay, 3 vertices. It doesn't work either. What? What? Let's I guess let's make a new polygon. Let's make a cube. Let's make a cube. So minus something, minus 4, let's say, minus 4, plus 4, wait, alright, it has to be clockwise, so if I have minus, well, no, let's do minus plus. Minus plus is top left, plus is top right. Plus minus is bottom right. Minus is bottom left. Okay, that's nice. If we go into edit mode and this does not seem to break. Well, I guess the test point is if I move this, that doesn't break either. Okay, that's nice. So this seems robust with 4. I wonder what test case this tests though, because so the top left is the first, so this is the first triangle that's checked, right? So and if it's inside here, right, then it's a concave vertex, right? So that's skipped. Okay, that's pretty trivial. So that's not testing the case that I had before. So I think we need at least we need one more vertex to try this. Let's make this a bit smaller. Like that. So if we have 5, okay, what's the case we want to test now? We want to check, I guess, right, that freezes immediately, okay? And why is that? Oh, that also freezes, okay. So there is some condition, right, where this causes an infinite loop. So I guess what it seems like is then happening, or what has to happen, like, is that there's some triangle that cannot be clipped. Like, there's some iteration of this algorithm where we go through every remaining possible triangle and none of them can be clipped.
My missus left me. I was in love with her.
So why could
I was destroyed
that
by all of that.
be?
You know, if it's happened to you, if you're listening to this and it's happened to you, then you'll understand.
I guess we could check if this triggers maybe. And less equal, I think we want to test less equal, or should we not? Because then that would make it, I guess, more. But it feels like incredibly edge casey, right? Okay, now that assertion fails instead. Oh. Oh, so is it literally, wait. Oh, okay, why is it working now? Why? Like, okay, is it literally when it's like 0? Literally 0. Is there some edge case I'm not handling? Because if I'm fast, if I'm fast at crossing this line, it seems to work. But okay, so if I try to make it exactly 0, I guess, like exactly on this point. Yeah, okay, there's some problems there. Are you fucking serious? Okay. Well, is that all? Like, yeah, it still fails this case. Well, that could be, I guess, also because I'm unlucky, right? Okay, it doesn't seem like it. Maybe. Okay, like what are the chances, and like how do I resolve this? Like, it shouldn't be a problem for the algorithm, right? Like, I should be able to give it this kind of geometry. Yeah. Well, except for non-simple shapes. Oh, hello. Hello, hello. We're doing very fine. Very good. I have a level editor, you see. Well, kinda. But it's very... There's a problem right now. It's not... The triangulation algorithm isn't very robust. So it's easy to make it fail. I think if I move this vertex, yeah, it's just, it freezes in an infinite loop. So I'm figuring out how should I debug that, really. Figure out why it's not terminating. So it's it gets into some kind of state where maybe I should check that first. So I guess I can print this size of the working set. Let's do that and see what the state is when it gets stuck. Okay, so it's always 5 here. That's interesting. So okay, so it's not stuck inside of this outer loop, it seems like. Really? Okay, so yeah, hell yeah. Printf, it's actually, especially for stuff like this, when like I want to see what the state was like before it actually crashed, right? Okay, so it's what? It's stuck in an infinite. Wait. Am I just? What could be wrong here now? So inner... It's not... Yeah, it's not printing anything. Like, what? How can it be... There's no other loop here that could possibly... Oh, wait, never mind. Wait, hold up. The working set size... Let's see what that is. Okay. Now this works. Okay, now it doesn't. Oh my god. Okay. I know what's wrong. So if I do... Oh shit. Like, okay. So at the last triangle, the way that this algorithm works, like I am going through this polygon and removing triangles at every step. And I guess I forgot basically, like if I remove the last triangle, I have to exit out of this inner loop as well. Right, so this is not the only condition I have to check. So I guess I'll also just check this. So we go through all of these, and if we still have 3 triangles in the working set. So we have to check this twice, right? Alright, now this is the only problem now. Maybe, hopefully. Can I make a failure case now? So I want some triangle that shouldn't be split because can I do that with 5? Yeah, that's probably it, right? So yeah, that's nice. So this would be okay, yeah, it seems to be robust now, or working. The only problem is this assert now. I can bring back my more complex polygon now. So yeah, we can edit the world now. Oh good. Okay, that's one more failure case. So we have okay, so we're on the last triangle. We're on the last triangle and it can't so that's gotta be yeah. So we have one triangle left. We have one triangle left, I guess. Well, I guess if we do only have a single triangle left, then there's no need to run the algorithm again, right? I guess. So we could change that, because yeah, what I assume, what has to be happening is we have one triangle left, and this condition is not met. Well, I guess we can check that as well. Not convex. Okay, let's try to make that happen again. Yeah, like that. Okay. So we are infinite looping on the last triangle. And all of these right. But that should not be possible. Well, I guess it is possible. Do we need some kind of threshold here, maybe? Or I think actually the simplest solution is to just, because if there's a single triangle left in this algorithm, then we can just output that. Like, we don't need to run this actual algorithm again. So we'll check if there's more than three vertices, which means that there's, I guess, yeah, 2 triangles or more. Then we'll actually run this algorithm. Otherwise, we just output the final triangle. That seems reasonable. And I guess, I mean, this might fail anyway, right? But maybe it doesn't matter in that case. And I actually wonder if this should be less or less equal. Okay, so when we're done, let's put an assert just so that the working set size should be 3 here. Like there should only be one triangle remaining. And those indices is just the the ones left in the working set. 0, 1, 2. Right. Oh shit. So it is wrong. He's wrong. Okay, so it does fail. Well, hold up. So I actually want to like add some validation before I actually try to triangulate it, right? Because there are some conditions that the polygon has to meet in order to make it triangulatable, right? Using this algorithm, and maybe that's just broken. That condition is broken. It's kind of hard to tell. I can't even find the... Okay, so this case fails, right? And then I guess the question is this... yeah, this should be a valid polygon. So it's something wrong with the algorithm in this case. Yeah, this is still a valid polygon, still valid. As long as none of the outer edges cross each other, then it's considered valid. Okay, but it still fails. So why is that? I wonder. And what happens if I now... Okay, if I make an invalid polygon, it just tries anyway, right? It tries anyway. It tries its best. Which, yeah, that should just output an error, I think, and not try even. Or it should signal some error, right, to the person who is editing the level. Right. But all right, so there are... Yeah, okay, whatever. Let's care about that later. So the real problem is that this polygon is valid. It is simple. However, this is still failing. So why would that be? I guess the main problem, I guess, is that this triangle should never have been created, right? It should never have been created. And maybe I got this logic wrong, actually. I have to think about it a bit more, because what I did... so for each triangle that we potentially want to create, right? We have to check every other point, every other vertex in the whole polygon, and see if any point is inside of the triangle we are trying to create, then we should not create it. We should skip it. And I wonder, right now, I do this test for all remaining, for all vertices in the working set. And maybe I shouldn't do that. Maybe I have to check all the vertices. I think we can try that first. Maybe that's the problem here. I don't feel like it is though. Maybe I can add some more debug drawing to figure this out. If I add back this code. So now we see the normals of every triangle, right? This fails, yeah. Well, I guess this happened because maybe I did it this because I assume this happened like this incorrect triangle now. This has to be the triangle, the last triangle. I assume so at least because this started happening just now. So if I skip that, then I am guessing that we won't see this invalid triangle anymore. Okay, my guess was wrong. We still see it. Okay, so it's not necessarily the last triangle. Okay, then maybe we should actually do this check. Oh, I see the issue. Wait. I forgot to go through every. I forgot. Okay, let's see how that works. Okay, that is working. Okay, makes sense. Okay, I have a feeling this should be very robust now. Except if you make a fucked up polygon like this. Right? Okay. That makes a lot of sense. Is the other project done? Which other project? This. Oh, yeah, I guess do you mean this like world generation, right? Yeah. No, that's on hold. That's just on hold right now. I was more excited for this right now. Because yeah, doing 3D stuff in general, right? It's a bit more involved than doing 2D stuff. Well, this is still gonna be 3D in some sense, right? But it's like gameplay logic and stuff is simpler. I mean, not that I don't even know what this is gonna be, right? It's gonna be some kind of platformer, right? Oh, bye bye. Oh, infinite loop. Okay, so I can't go too crazy on this editing, right? Okay, now what? I guess I could... I could maybe try... Yeah, I have no idea actually. I could try saving this state, maybe. Save the editing state to some file, right? So that I could potentially create a level. That's gonna require some stuff though. Well, ooh, I can I can try to. I can try to make it possible to add more vertices, right? Because right now I can only move vertices around existing ones. Right. That's not good. Oh well, okay, so I can try doing that. Okay, so I want to be able to insert new vertices along these edges. I guess I can do that by just clicking on the edge, I guess, somehow. Alright, so I think one... I wonder what the controls should be for that. I feel like something like holding in control, maybe? If I hold in control and click on an edge, then yeah, let's do it like that. So, okay, how to reflect that? I guess for now we can just have like a we can have an insert mode, I guess. So we have two modes. We have the like moving around the vertices mode, and we have an insert mode. Okay, and we have to check for key presses. I wonder if I have that key, so yeah. So if I press Control, oh, key code, okay. So if I press Control, we go into this insert mode. And if we release Control, we leave the insert mode. Okay, makes sense. Okay, so what should the difference be now, I guess? So if we want to insert some point, I don't think it makes much sense to actually highlight the vertices, right? We want to highlight the edge, right? We want to highlight the edge instead. And right now, I want to... I still have this debug rendering. Where did I put that? Is that in the... Okay, that's here now, right? So if I remove that debug rendering stuff... Okay, I still see the triangles. Let's hide those as well. Debug stuff. Okay. Okay, nice. Alright. So... Okay, now I can use some debug drawing to draw a line here, I feel like. But how does that actually work? Let's see. So when we are in the not insert mode, we do this. We just pick out the polygon in our world and we go through every vertex to find the one that's closest to the mouse. Right, makes sense. However, if we want to insert some... oh. It's not the game, it's editor. But if we're in insert mode, we want to, I guess, somehow go through every edge instead, right? And check which edge is closest to the mouse. Okay, so now when I hold control, yeah, this disappears. So let's replace that with finding the closest edge. And I've done this so much already. Like, the thing... What we want to do... I guess there's kind of two parts to it. One thing is that we want to define some plane, right? That lies on the edge. Then we can calculate the distance to that plane from the mouse. That's simple. However, that like plane equation assumes that the plane is has infinite width or infinite size, right? So I wonder how to accommodate for that. I guess if we have a plane, we could also, it's gonna be difficult to, but if we have some plane along this edge, for example, and it's pointing upwards here, I guess what we also can do is just define two other planes that point towards the tangent, right? So one plane pointing in this direction, out from this vertex, and pointing out here from this vertex. And then I guess we just check if the mouse is behind those two planes, and then we can check the distance from this plane, the normal plane. Okay. There's probably some like more clever way of doing it, but it's kind of easy to create planes and use those to do this kind of stuff. Okay, so I guess we can start with we still want to go through every vertex, right? Yeah, and we need the next vertex, so I+1, and we have to make that wrap around, right? And then that means we will have some position A and B, which is the position of the two vertices that make up this edge. Alright, and then finding the normal is simple. I think I memorized it by this point. So it's well, okay, finding out the normal first, we create a vector AB. Well, no, let's call it V, because it's gonna be normalized. So we normalize the AB vector. So the vector is pointing from the first vertex to the next one. That's this vector, direction vector, and the normal of this plane is just this. And there's so much. I can steal this debugging function from somewhere else. So if we figure out the center now of this edge, and we have the normal, we can visualize that in a nice way. Like that. Let's just try that. Okay, that works. So we have the normal. now, okay. When I hold control, okay. And we also want these other normals, so the other one, this is gonna be simple as well, so we just I wonder if we don't even have to draw this, but let's so this vector is pointing from A to B, so the plane we want to create is going to be centered at B and going towards this vector, this tangent vector. We could call this tangent actually. Right, so we have the tangent. Yeah, that seems right. Pointing in that direction. And the reverse tangent is going to be centered at A. And that's going to be just a negative tangent. Right? Seems right, okay. Alright, so now if we have these tangents, right? Let's assume this plane. So we have these tangents. If we create two planes of those, and check if the mouse is inside of those two planes, or like behind both of them, right? Then that means... Yeah, that means that we should potentially select this, or pick this plane as the closest one. And I actually see a way now of making this a bit easier, I think. So we can, instead of caring about these two planes, we can just create one plane that's pointing in the tangent direction at the center here. And all we have to do is check the distance and take the absolute value of that, because that is going to be extended as far in both directions. Yeah, equally as far in both directions, and we can just take the absolute value of that and compare it to half the size of this edge. Okay. Let's do that. So we have we're gonna create the plane, the tangent plane, which is going to be the tangent x, tangent y, and the distance from the origin is gonna be dot product from the center and the mouse position. Right, and then actually I'm gonna do some printf debugging here, so let's just hard code this to test a single edge. So the dot product now of the tangent plane well, the tangent plane, we have the tangent wait, I feel like something can be wait. So the dot product Okay, so it's minus minus this. Right. So the final. Where were I in the editor? Right. So that's gonna be minus tangent well, oh, like that. Is that correct? Oh, let's just see. So that will be some distance from the center along the tangent plane, or along the tangent normal. Okay, so let's print that. Do I still have printf left from my triangulation? Yeah. That's gonna clobber my output. Okay, so we're testing plane 0. Which one is that exactly? Plane 0 is going to be -5. So I think it's this one, right? That seems strange. So the flip is here. Okay, I got something wrong, obviously. I guess I can also try to use this to actually... I can draw a line, I guess, so between the center... from the center to... yeah, in the direction of the tangent, yes, times this distance that we got out. And that should show us something, at least. So let's see. Oh, there's so many steps now too. Okay. Okay, that's obviously wrong. Oh well. Okay, one way of thinking about this, I guess, is we're just projecting. We are projecting the position of the mouse onto this plane, right? And it's reversed, and it's not like centered around the right place. So how... Did I get this right? We have a lot of... So the plane, yeah, is defined by the direction, right? Yes, direction, and the dot product of the direction and where, and some point that we want to lie on the plane. Oh. Well, do we do that? Wait, and then this... Oh, wait. Okay, wait. Oh, shit. Oh, my text editor. So what am I actually doing here? Right. So this should... Right, okay, this should be the tangent and center. Right. That should work, I hope. Yeah. Except that it's reversed. Yeah. But that shouldn't even matter because I want the absolute value of this. What? Oh, shit. It's what? It's integer absolute. Is there no floating point absolute in? Is f abs? Okay, so there is apparently. What header though? TG math? What the fuck? Type generic? Okay, it's in math. Okay. Do I not include math already? No. Right, so it's f abs f. Okay. Okay, that's nice. So now we just have to check if this value is lower than half of the length of this edge. Right. So we take the length of the vector AB, and if the distance is below, right, this one, this fucking sucks. All right, then we know. Okay, well I guess we can check if it's larger. We just don't care. Do not care. Okay, I do not care. Okay. Well, I actually think it would be cool to have this. Wait. I'll bring back that debug drawing. All right. So if the distance we have is larger than the length, just don't care about this edge, right? Okay, so now we can start. We can go through all these now and see how that looks. It looks dank as fuck, but it's correct, right? We've essentially projected our mouse position onto every single line. Yeah. Cool. can add that after, so that it's not too messy. So right, it has to be larger than the half of the length. Makes sense. So now we have some set of edges to consider, right, to be the closest. And now, out of all of these edges, we can just check the normal plane, right, to get the closest distance. All right, so closest distance again. Yeah, and we'll have some closest edge. All right, so to figure out the actual, let's call this tangent distance, edge length. Okay, so that's the tangent test. Right, and I think we want to do the exact same thing here, except with the normal instead of the tangent. I think that's literally it. So then we have the normal distance here, and we can draw that as well. Make that green. And along the normal, right, and use the normal distance. All right, that looks correct. Yeah. Okay, so now it's just a matter of picking the smallest one out of these, and that should be yeah, that is just the closest edge, right? So the normal distance is larger than the closest one we found so far. And let's reference the edge by the first vertex index, so that's just I. Right. So if we found some closest edge, we can start by just debug drawing that. Let's remove these first. Alright, so let's debug, let's draw that edge if we found a closest edge. Let's make that red. From A to B. Closest edge. And the closest edge +1 wrapped around like so. Okay, what's wrong here? Right. Forgot. Okay, that works. That works. Fine. So we now know which edge is the closest to the mouse. Perfect. Perfect. Okay. Okay, cool. So now I think now when I click the mouse and I have a an edge selected, I just want to subdivide it. Like I want to add a new vertex there. Right. I want to add a new vertex. Right, and we need this to set this closest polygon and closest vertex as well. And that's going to be the closest edge. Yeah, okay, sure. And let's just reset this every time in case we don't find any closest one. Then okay, so how we have the polygon, right? That is the closest. And all we have to do, right? I mean, all we have to do, just insert a new point, right? And I would want that point to be where we are clicking right now, right? So how do we do that? We have the polygon. And we have all of the vertices. So it needs to be ordered. We want to insert it after this edit vertex, like after this index in the array, right? So we just check the polygon and we have all of the positions here. So we basically have to go from the back of the array, right? And for every element we just move it to the right. And we move it backwards. Yes. So I don't really like making reverse loops in this way, but yeah, it's gonna be simplest. Okay, so we start at the end. We start at the last element. And while what's the condition here? we want to go down to this current edit vertex, right? So something like that. Question is if it should be greater or greater equal. It should be greater equal because we will land at this vertex. Wait. No, I think it should be greater. Okay, let's just try that. And we will just move like that. Move everything back. Right, and we will increase the vertex count by 1. And we will assign the new position to where the mouse currently is. And we can do that with this, right? Yeah. This, close this. Don't have space. Let's see what happens. I think this should be it. Well. We also. Oh, this shouldn't be the edit polygon either. This should be the closest polygon, right? Because we're not editing it yet. Okay. This should all be the closest polygon. And the edit polygon. Just assign that now, it should be the same polygon, and now the edit vertex is going to be the index of the vertex that we just inserted, which is closest vertex also, which is just the same, I think. The best way of finding out is just testing, right? So. Okay, that. Oh, Jesus Christ. Okay, something went wrong there. So let's assume. Oh, I think this is something's wrong here because okay, let's say we want to insert a point on the edge between I guess vertex 0 and 1, which is this one, I think. So the new vertex should be placed in the middle, so it should be on index 1. Right. So. The closest vertex plus 1. That's the new vertex index. That seems to have worked. Yeah. Yep. Oh my god, I can make a giant world now. Oh my god. I love it. Okay, that is awesome, actually. Really nice. This is not awesome, however. Fucking awesome. And there is some upper limit now. So at some point there's a limit of 64 vertices, I think. So at some point we're gonna start writing into some random memory, which is not good. I think it happened. No. I think that just happened. Or maybe. Oh, I think we ran out of. We probably ran out of vertex space for all of these flowers. Like that's probably a lot of flowers now. Probably. So that will have to change somehow. I probably do want to scatter these flowers every frame, but I need to do some culling first, right? Have to do some culling. Yeah. And it would be cool to get some more variation on the models. Maybe I can do that now. Like, what would be a nice, simple, distinct type of flower? I have grass straws and this type of flower. Not sure. I really want to. I want to fix this wind animation as well. It's just using the position. Position right now. They're like squished. They're using each individual vertex position to calculate the wind movement, which they should be using kind of the same position to do that, so they're not squished around. Yeah. Yep. But I really love this. I love this. And maybe the next step is to actually create some kind of, I guess, probably a file format or some kind of serialized format, right? To save this level, so that we can save the state somehow in a file or something, and then load it, so I don't have to, So we can maybe design a real level, right? And have it persistent. That would be nice. Would be very nice. All right, but I think that's probably gonna be it for now, at least. Probably for today. But that's very nice progress. Let's call that level editing, well, world editing. That's basically it, right? Yeah, that's it. Good description. Right. All right, very cool, very cool. But that's it. See you later, bye bye.